Okay, I'm getting ready to assemble the flow cell again. Got a new membrane. That's been loosely siliconed in. The bolts aren't bolted up, they're just clamped. I've coated the stainless steel with the conductive ink to protect it, and those little rails. This one's a iron 3 hexacyanoferrate one. It's gone white because I had it on those graphite plates in some zinc bromide as a supercapacitor, but that didn't run as good as that little one, so I chucked it in the microwave and cooked it, and when it's in the sun it goes white. This is the zinc hexacyanoferrate one for the negative side. I've also coated this one. This one doesn't need to be coated. These came from the positive one. See how the pitting from the bromine ate into it, as well as down in there, around the corners. This one probably didn't need to be coated, but I coated it anyway. The bolts are nylon now. I've got them screwed up and sealed with some silicone, so hopefully they don't leak. So that should fix the bolts coming loose by getting them corroded away, which happened really quickly, probably in the first charge, and these plates fell off. I also put some of the ink under the plate and glued it as I bolted, so they should be fixed quite well. Resistance is quite good. I made some plastic ones to test in the zinc bromide capacitor. These are really good in conductivity. I've dipped them 6 times. I have some copper tape, and that's for the connections to go. That's for another experiment later on, but that's a cheap alternative to making a collector plate. It works really good, but the zinc bromide hit the copper and ate it, so I recoated them. So zinc bromide will eat any metal, seriously, badly. I think it eats steel less than the other steels, but I'm not quite sure on that. Membrane's a bit floppy on this one for some reason, but it's still in there, should still work. It's got 2 coats of cellulose acetate on the cotton. So I'll assemble that, let it dry today, maybe tomorrow, get to see if it works. Hopefully it runs a bit better now, but we'll find out tomorrow or whenever. Okay, I got the flow cell put back together. Had a slight leak. I think it's stopped now. We're at 2.8 volts and we're pumping in 1.7 amps. That might be enough. I'll keep an eye on it. I've got to keep the amperage up. So I've just started the monitoring. The electrolyte's turned brown, so I don't know if it's any good or what. The good news is the windscreen wiper pumps are still working, and so are the aluminium one-way valves. So this is the positive side tank. This one's the negative side tank. I have some good thick leads coming out of there now. They're bolted in there with some brass bolts. I got that one designated as the positive, and that one there is the negative one. So we'll keep the amperage up to say 1 amp. I won't drop under 1 amp. If I drop, I'll increase the voltage. So fingers crossed. I think it's pumping in more amperage with the conductive ink and everything, and the carbon felt pads. So I'm not sure we're actually going to get a colour change in our electrolyte now. It had some contamination from the stainless steel plate, what got eaten away somewhat. So I'm glad those pumps are working. We're at 24% on the pulse width modulator. I'm not sure if I should cycle it or stop it. Let's have a look what happens to the amperage when we stop the pumps. I think that's the power supply. I thought it was hissing. Oh yeah, the amperage has gone down now. So we'll cycle it through. That thing's great. Oh yeah, we're going back up in milliamps. I'll keep it cycling, I think. Oh no. Shouldn't have stopped that, look. Ah, crap. No, I'll keep it cycling, it's slowing down. Oh, where is it? I can't see it on the camera. That bolt there. It stopped. Phew. Alright, that solves our problem. We'll keep the pump running. Don't know why it leaks when the pump's off. Weird. We've got another leak over there. I put so much silicone on it. Obviously I didn't put enough. Alright. Yeah, it's been charging for 52 minutes. I think the negative tube here is getting lighter than that one. That's the positive side. It seems to be dark compared to that one, and a lot of bubbles coming through the negative side. They're moving quite quick. And I can't see any on that side. We're still 1.8 amps. Charge for 6 hours and 19 minutes. Doing around about 2 amps. It spiked up here, it was going up in amperage, so I dropped it back down in voltage to get 2 amps. And it's been sitting there. It's not even leaking that much. So a little bit. That one's sort of draining out a bit. That one's getting a bit fuller. I think there might be a slight colour change, not sure. That looks pale, that one looks a bit darker, but it's hard to tell. There might be a slight difference in colouring. So I'll connect the other end of the data logger, stop the charge and get back. Okay, the voltage is very low. I'll start a discharge. It's only 50 milliamps. Alright, hopefully it holds for a bit, because I'm not sure what's going on with the electrolyte. Maybe it needs more amperage, or it's just the electrolyte's going all funny. So far the cell's been running for 4 hours and 33 minutes, so there's very low voltage. It's been holding that voltage for a while, but it's only done 228 milliamp hours and 65 milliwatts. So that's with 50 milliamps. Let's see what happens when you adjust the load to 100. Okay, so we can draw 100 milliamps. That's still alright. A joule fief might help with the voltage. See what happens when we stop the pumps. Nothing much. Turn them back on. Yeah, definitely better with the pumps running. Alright, I'll leave that for another half hour. Okay, it's been running for about a half hour on 100, so I'll try setting it to 200. Hmm, 0 volts, so and stopping. Okay, we have some voltage bounce back. I'll give it another charge some other day and see if it improves. So we got a total 300 milliamp hours and 77 milliwatts. Okay, it's the next day. Both containers seem to be this greenish colour now, so that would suggest part of maybe the steel tubes, the stainless steel tubes I'm using, which you can't sort of see there. Down in there might be corroding, or some of the conductive ink might be coming off the positive plate. Won't be able to test it for a while. I think this tub's leaking somewhere, but I don't know where. Must be out around the ring. Seems to have stopped dripping. So we'll give it another charge, just in case the membrane wasn't totally saturated and wet yet. Had 2 coatings of cellulose acetate on that membrane, so it normally takes a couple of days to seep through. Okay, just setting up the flow cell again. Today it's about 2 days later, sitting at 0.6 volts with the pumps running. No load at the moment. I was just monitoring the flow of the liquid going through. So I'll set up a charge. I'm gonna try 2 hours, probably around about 3 amps. See what happens. Don't have much time, so also gonna do a 100 milliamp discharge, so get rid of it quickly. Okay, I got the voltage set to around about 4.2 there, 3 amps, 4.4, 3 amps. Still got a leak. Starting to form weird little crystals in there. Got a bit of liquid left in the positive side tank. Both tanks are going the same colour, but that one, as you can see, is a bit clearer. There's liquid flowing through, just seeing some bubbles, and that one's gone blue. There's the bubbles coming through. So I'll let that charge up for about 2 hours. That way I've got 2 hours discharge time. I slowed the electrolyte flow down to 20%, and there's some, so a lot of bubbles coming out of the negative side at 3 amps. So it's making hydrogen, I guess. That's a lot of them. Maybe I should increase the flow. And we're dropping now. Oh, look, it's like almost a continuous stream of bubbles. Maybe it's just evacuating them better. Okay, cell's been uncharged for 2 hours and 30 minutes. I've got it disconnected. It was doing around about 3.2 amps for 2.5 hours. It's holding 1.2 volts, which is a bit better than it was yesterday. So the membrane must be sort of good. So starting the test. Alright, we're 100 milliamps and we're at 1 volt. Cool. voltage looks okay. We have a lot of gassing. That's 3 amps going through the cell. Mainly on the negative side. There is bubbles sometimes there. I think that was one. Yep, there we go. On the positive. Colours of the tube, bit darker there. Not so dark there. Leaks like a sieve if I stop the pumps. Coming out of that bolt hole right there. Just under that yellow one on the left of that yellow clamp head. So, I'm impressed with the voltage. So the membrane sort of must be soaked. Definitely like the extra amperage going through that cell. And it was only like 2.5 hours. Yesterday was like somewhere like 6 hours. Okay, I'll see how long we can run this for. I only have a couple more hours left in the day to do this. Okay, we've been running for 1 hour and 25. I just switched it up to 200 milliamps. And voltage dropped a fair bit, but still holding 0.188. So I'm still gassing while it's on a discharge. Both sides are now. Positive side's gassing out as well. Nowhere near as much as that negative side there. To wrap it up today, we're at 200 milliamp hours and 114 milliwatts. So let's see if it actually can do 400 milliamps. I'm readjusting. Oh no, it's only got 350 and dropping, so it can't really do that at the moment. Let's increase the gas again. No. I can try it again tomorrow morning for a bit. Probably get another 2 hours, 3 hour charge if I get up early enough. It's still got 300 milliamps in it though. Needs to be drained, but I can't leave all this outside. Alright, till tomorrow. Oh, let's have a look at the voltage bounce back. Okay. Still gassing. It's only 26, it's around about 33 on the table, so it's quite cool. Pumps are alright, got it down to 18%. And we look like we're going to probably bounce up to 0.45. Alright, we'll see the voltage tomorrow. Okay, getting ready for another charge. Voltage is much higher today. It's 1 volt and climbing. So I'll set up the charge and get back. Okay, cell's been on charge for 4 hours. It's holding 1.2, ready for 100 milliamp discharge starting now. Okay, we dropped to 1.1. The electrolyte's a bit darker there on the positive side, a little bit lighter there, especially through the tubes. I was putting in around about 3.6 amps at the start on the charge. I tried 4 amps, but these little leads here are heating, they've started heating up, so 3.9 is the maximum amperage. The leakage is crystallizing. Alright, I'll let that run and get back. Just increased the flow rate of the pumps there to 33%, and we're getting an increase. Oh, I started leaking. I might have to drop it back. So there's an improvement with the extra force going through the cell. I think it's still increasing, I reckon. Okay, 24% stops the leak, so it's not ideal. I think increasing the motor speed gets rid of the bubbles, which probably increases the voltage by the looks of it. So yeah, as we get the bubbles now, starting to lose our voltage again. So when I redesign it, I'll seal it up a bit better. Going to increase the load now because I've only got about an hour left. So I'm setting it to 200. Okay, today's run, 1 hour and 41 minutes. Capacity 243 milliamp hours and 122. It's turned brown now, so it's probably in its discharge state. That's sort of a lighter brown compared to that one. I'm going to see if I can hook up this step up voltage for a few seconds, so I'll disconnect and get back. Okay, I've just finished stripping it down. Any longer run on that, that's the positive plate. It's etched about 1 millimeter thick groove right around feed by that lip. So that's where I scraped the ink off of those little joining plates. It's somewhat held there, but due to the charge, because I also painted the nylon screws with conductive ink, so anywhere where there was a current going through it, it sort of lifted the ink off the plate. But the negative side's good. I've scraped that and it's still holding on. So you don't even really need to plate the negative side, so you could use stainless for the negative and something else, conductive ink and plastic or something, I reckon, for the positive side. All that looks like iron has been stripped out of the cell, out of the stainless plate, and plated itself onto the membrane. That was the side facing the positive plate. it sort of made little balls. It's quite hard and stiff. And for the negative side, it's sort of plated carbon. And probably zinc, maybe. Would be some sort of zinc in there. I think some of the iron was actually getting through the membrane. So, needs a redesign. Get rid of that stainless for one issue. We might have a half a chance of making it work. That electrolyte's probably contaminated now, so I'll leave the lid off and let it dry out over the summer. Back to salts. And I can dispose of it easy. The ink stayed on the pads, that's where I scraped it off. It took a bit of scraping, so zinc bromide doesn't eat through the ink, but it will lift off where you're charging to. So another couple of hours or more on that and it would have ate completely through that plate. Well, I'm amazed it actually worked for a bit, considering it's very corrosive to metals. Doesn't sort of look like it dissolves the iron, but it probably does. It turns it into that powdery iron substance. There's probably not a lot of nickel and chromium and manganese in there, in the stainless anyway. It's mainly iron perhaps, or higher concentration of iron. Okay, well, thanks for watching, and I'll get back with a flow cell when I get some spare time and a redesign. 3D printer might help make that process easier. I could print the plates, paint them with conductive ink, and be done with it.